Hello and welcome back to Verbose Mode by TaxCare at Basel 1 2025. Gerrit is my next guest. Hey! Welcome, Gerrit. Great to have you back. You mentioned that you have obviously tons of content to talk about, and you also mentioned something that I think will be very, very interesting, especially for our audience. It's called CRAC.
Oh yes, I have CRAC, man.
I love the name. I hate the name. But it is actually an acronym, right? CRAC stands for
Coordinated Restore at Checkpoint.
Coordinated Restore and Checkpoint.
At Checkpoint.
At Checkpoint.
Yep.
Which is just four completely unconnected words for me.
Okay, let me explain it in a very easy way, because you probably use it all the time and don't know what it is. So if you have a laptop, right, and you just work like this one, and then in the evening you just close the lid, and you expect the next morning when you open it, everything's there, right?
Well, theoretically.
If you have programs open, usually they keep it open, and yeah.
I remember times when it was the desired behavior, but it didn't really work that way, right?
Yes, I remember these days too.
Yes. No, but generally, yes. This is the assumption, of course.
And what happens in the background is the operating system detects that you close the lid, and it will create a checkpoint. That means it stores everything that is in memory on the disk in a so-called checkpoint file or multiple files. And then the next time you open it up, it will see, oh, there is a checkpoint, and will restore everything back to memory. And that is pretty fast because we have SSDs, and it just goes directly back to memory, and the programs will continue running. This is in principle checkpoint restore. That's the idea, right? So you stop a machine, save the state to disk, and when you restore it, you just load everything back into memory, and it works, continues working. That's the important part. It continues working. It's not a restart. So let's say you have Word open with a document. You close it, you reopen. Word is there with the document at the same state as you left it.
Word even didn't know that something happened.
Exactly.
There is completely not interrupted.
This is the idea, right? But now we port that to the JVM.
So that's the next question. How does it help with Java?
Exactly. So you have the problems with JVM startup, right? Because if you start a JVM application, then usually what happens is it loads the bytecode into the memory, and then first of all it starts with interpreting code, right? And that takes some time because it has to go line by line through the bytecode, and then for each bytecode it's a so-called template interpreter. That means there's a snippet of machine code. So it's like a huge switch state call, and it will just go through each bytecode statements and will call the machine code and execute it. So that means the JVM is profiling that and looking at the code that is executed and figured out, okay, there is methods that will be called quite often, right? Then there are specific thresholds like 1,000 times. I think this is in JDK 17. If you call a method 1,000 times, then the JVM decides, okay, you know what, this method is lukewarm because we used it already quite some time, so let's compile it. And it forwards it to the C1 compiler in the JVM. So the C1 compiler takes the code, compiles it pretty fast because this is the former client compiler, and then doesn't do any optimizations, right? The code is a little bit bigger, but it's fast, it's compiled. Then this compiled code will be executed, and then there's another threshold because the JVM is still profiling and see, oh, this already warm method now gets hotter and hotter. And so if it reaches, for example, 5,000 times calls, then the JVM decides, you know what, this is really a method we should really optimize. So it passes it forward through the C2 compiler, which does lots of optimizations there. So then the code gets really fast, takes some time. And this whole procedure can, depending on your application, can take seconds, right? And usually in the times of monolith, that wasn't a problem because you start the application server once and it runs for a month, right? When we go to microservices, then the stuff starts up, runs for a minute, goes away. So you really would like to have full performance as fast as possible, but you won't get it sometimes. This is where GraalVM, for example, comes in with all the native image stuff, but it has different problems.
And Go, I would say, where it comes.
Yeah.
This is why a lot of cloud native code is written in Go, because it doesn't have this problem.
Exactly. So, but there is the idea that we can overcome this problem by just imagine you run the application once and you warm up everything, and once it's really warmed up and everything's highly optimized, you just create a snapshot at this specific point, store it to disk. The next time you restart, you just restore from the checkpoint. That means only load the stuff back into memory. That takes 100 milliseconds, and that's it. And you have your fully warmed up application ready to run, right? And it continues running. This is the difference. That means everything you did until that point is in the checkpoint. That means even if you load data, it's in there. So you have to be careful, right? So you don't want to have some, let's say, time-sensitive stuff in the checkpoint. So like, let's say you have some documents that are time-dependent. So that means I sent you a bill, or I prepared it already, it should be sent out today, it's in the checkpoint. The next time I restore it, it's still in there, but it's now overdue.
Yeah.
So you have to be careful of these kind of stuff, but there are solutions to do that. So this is the main idea, right?
Okay, so what it means for me as a developer, if I know that, for example, I'm going to load this application to a Java container, to a Docker container, it will be part of my microservices cloud application, and it will be killed a lot, and then it will be started a lot. What I can do is, when I have a release, I'm going to run it for a while under some stress.
Exactly.
To make to force the JVM to optimize it as much as possible. I run it for hours, for days under stress.
Depends on the application, yeah.
And I guess probably I can look somewhere and see.
That would be nice. Unfortunately, this is so dependent on your application that there is no general mechanism where you can figure out, oh, is it now really hot? Right?
Yeah.
There's a way to do, you can log out all the compiled statements and you can see a decrease of number of compiled statements. So at that point, you know, okay, now it's...
Okay, there is nothing going to happen further.
Yeah, exactly.
And then I can save it.
Yep.
And this is the Docker image that...
You save this, it's not the Docker image, you save this file, which is just the state of the JVM,
which will be
with
part
your
of
Docker image, and then you can deploy it. That could be a problem because it's more or less a heap dump, right? So that means if you have a large heap, the file will be large, right? We do a very aggressive garbage collection cycle directly before the checkpoint. So that means only keep the stuff that's really live, but still could be bigger. To avoid that, you could also put this image or this checkpoint file in a, let's say, Kubernetes volume. And then all the services just point to that volume, load it from there. So you just have one place. And when you start up the services and scale it up, everybody takes it from the same point. Means container is the same size as before. You just have one additional file on your Kubernetes volume where you just, this is one way to do it.
Nice. That sounds like a really, really smart and good idea. How useful it is? What are the tools that allow me to do all this process as easy as possible when I do the release? Yeah,
so it's like there's one tool that comes with the JDK, which is Creo, or not with the JDK, so it comes with Linux, right? So this is Creo, which is a tool on Linux to do exactly this, but with applications. You can't just use it to checkpoint a JVM, because the problem with the JVM is inside of the JVM runs your application, right? Your application has, for example, a connection to the database. So you can't just simply create a checkpoint and assume the next time you restore that the connection is still there, right? So it will break because there's no connection to the database. So we implemented, and that's the reason why we created CRAC at Azure, is we added a library called org.crack, which has an API, just two methods, and you implement it on the right points, for example, in your database manager, and this will be called directly before we do a checkpoint. It will close the connection. When you do a restore, it will re-establish first and then restore to make sure that this works.
It's like the serializable.
Yes, somehow.
That we have the what to do before we serialize
Yeah.
and send it over the network, what we do after when we restore from there.
But this again comes with another problem, because if you run on something like Spring Boot, you can't really close the stuff before, because this is somewhere in Spring Boot.
It's
right?
managed by third-party lifecycle manager.
Lucky us, there is support in Spring Boot. Quarkus has some rudimentary support, and Helidon has support, and Micronaut also has support for checkpointing. That means there you don't have to do anything. You just create the checkpoint, and the framework will shut down and will take care that everything will be restored afterwards. So this is really nice, yeah.
Nice.
And it can improve startup times from, let's say you have Spring Boot Pet Clinic, and on my MacBook, it's an older one, runs it starts up in 4 seconds, standard. If I do the checkpointing, it can start up in 130 milliseconds.
Wow,
and you are
that's
up
a huge
and running.
difference.
And one big advantage, depends on the application, in comparison to GraalVM, is they can just improve the startup time. But with this one, for example, in the Pet Clinic, you could modify the application for a specific customer, because some customers might already have some data in the database, right? So in pet clinic, for example, I could add me as some, or my dog as a patient for the doctor, and then I create the checkpoint. The next time I restore, I'm already there.
Yep.
This is something you can do.
It makes sense for data which is persistent and you
it's
want
not
to
for
preload.
everything, so it doesn't mean that GraalVM is useless, but it has its points where it's really useful, right? So that's in very short what CRAC is.
That was perfect. That's exactly how we like it. Very short, consumable bites that we learned, and we did.
Perfect.
Gerrit, thank you very much.
My pleasure.
It was great, and you all stay tuned for more episodes of Verbose Mode by Attacks here at Basel 1 2025 that will come to you right after this.